Here we want to solve the rational inequality and write the solution in interval notation. So if we take a look at step 1, we have 3x over x minus 9, and that's less than 1. So currently, we want to make sure, currently right now, 1 is on the right-hand side of this inequality. We want to make sure that we get a 0. So the next thing we want to do is we want to be able to subtract 1 to both sides. So we have 3x over x minus 9 minus 1, and that's going to be less than 0. Now 1 as a fraction is 1 over 1. And what we want to be able to do is to combine these terms with an LCD. Well, the LCD between 1 and x minus 9 is x minus 9. So what do we need to multiply x minus 9 by to get x minus 9? Well, that's 1. And what do we need to multiply 3x by? Well, that's 1. So 3x times 1 is going to give us 3x. Okay, 1 we need to multiply by x minus 9 to get x minus 9, which means we need to do the same thing to the numerator, which is 1 times x minus 9, which gives us x minus 9. And therefore, that is less than 0. So now what we're going to do is we want to be able to distribute this sign and write them under one denominator. So we have 3x. If we distribute that sign, it becomes minus x and then plus 9. And that's all over the common denominator of x minus 9 to be less than 0. And therefore, if we combine like terms, in the numerator we get 2x plus 9 over x minus 9, and that's less than 0. Okay, so now what we want to do is we want to be able to determine our critical points. So in the numerator, we have 2x plus 9, and we're going to set that equal to 0 and solve for x. If we subtract 9 to both sides, we get 2x, which is equal to negative 9. And if we divide by 2, we get negative 9 over 2 as one of the critical points. Okay, and then in the denominator, which is a restricted value, we have x minus 9, set that equal to 0, so x equals positive 9. So therefore, there are our critical points. So over here, I'm just going to draw the number line. So we have 0, we have negative 9 halves, and then over here we have positive 9. So now we're going to create our regions. So we know that we're going to have 3 regions here. So we have region 1, region 2, and then region 3. Okay, so we're going to start at negative infinity, and we're going to go to negative 9 halves. Well, if you look at the inequality, it doesn't have a less than or equal to. So that means we're going to be using a parenthesis here at all the points. So the first interval goes from negative infinity to negative 9 halves. Our second region has an interval between negative 9 halves and positive 9. And then our third region goes from 9 to positive infinity. So now what we're going to do is we're going to select testing points from each region. So if we take a look at region 1, we have negative 9 halves. Well, that is the same thing as negative 4.5, so we can pick x, which is equal to negative 5. And then we're going to plug it in the inequality, 2x plus 9 over x minus 9, and we want to see if that's less than 0. So we have 2 times negative 5 plus 9 over negative 5 minus 9. So we have negative 10 plus 9, which is negative 1 over negative 14. And so therefore, that gives us a positive value, 1/14. And is that less than 0? Well, that is false. So we know it's false in region number 1. Okay, if we take a look at region number 2, we can let x equal 0. So we're going to plug it into the inequality, 2x plus 9 over x minus 9. So we have 2 times 0 plus 9 over 0 minus 9. So we get 9 over negative 9, which is negative 1. And negative 1 is less than 0, so we know it's true for region number 2. And let's take a look at region number 3. If we pick the value of 10, so we have 2x plus 9 over x minus 9. So we have 2 times 10 plus 9 over 10 minus 9. Well, 2 times 10 is 20, plus 9 is 29 over 1. And is 29 less than 0? Well, that is false. So now we can determine where the intervals are true. So in region 2, we have the only interval where it's true. So therefore, our answer is negative 9/2 to 9.